In this presentation, we're going to look at some examples from integration by parts. So the integration by parts technique is we have an integral. We're going to structure it as a component of two terms, u and dv, okay? And this, to solve it, so we have one term that is u, one term that is dv, and to solve it, the integral is evaluated as follows: u times v minus the integral of v du. Okay, just for the sake of legibility, I have a little sort of line just coming out of v for v, because u and v are look very similar when you handwrite them. So the little wave there looks sort of like an R actually in some ways. Anyway, that's v. Now the thing about this is, how do you decide which term is u? Well, there's a little chart. This will become obvious later on. Which one's going to be u? Which one's going to be dv? So there's a rule of thumb we would use. This is the order of precedence for u. So if you have two choices, the nearest one, or the first one in order here, starting from the top, is the term that should be the u term, and the other term should be the dv term. So the first term is logarithmic term, so log of x, let's say. The next one is inverse expressions, for example, cos minus 1 of x, okay, or sine minus 1 of x, or something like that. Polynomials, so something like x squared, x cubed, something like that. Those are polynomials. Exponentials, such as e to the x, e to the 2x, e to the 6x, let's say. And trigonometric terms like sine x and cos x, those would be the last choice for u. So this is the Lipet rule, L-I-P-E-T. Actually, in other books it's known as the L-I-A-T-E rule, where A is for algebraic, which is just polynomials by a different name. L-I-A-T-E, and the exponentials and trigonometric, it doesn't really matter too much about the difference in order between those. So here's our first one here. Okay, x times e to the x dx. Okay, so according to our polynomial, our Lipet rule, this component here is a polynomial. This component here is an exponential. So necessarily the u term should be x, and the v term or dv term should equal e to the x dx. Okay, so that's the key part of this done, the Lipet rule. Just go back there a second, scroll down there again, which in order of precedence, which should be used. So polynomials precede exponentials in precedence. So what we need is du. So let's integrate u to get du dx. So du dx is equal to 1. That's just deriving and get the derivative of x. And rearrange that algebraically, we get du is equal to dx. Now, to find v, that is the integral of d of v. Okay, so that's the integral of e to the x dx. And the integral of e to the x dx is simply e to the x. Okay, so v is e to the x. So we have everything we need. We have u, we have v, and we have du. So now all we have to do is put that into our equation. And again, our equation was u v minus the integral of v du. Okay? So u times v is x times e to the x minus the integral of v, that's e to the x, times du, and in this case du is simply dx. Okay, so the integral of e to the x dx is actually, again, just e to the x. So this is x times e to the x minus e to the x plus c. So that is the answer to the first one. There we go. Let's write that in again. X times e to the x minus e to the x plus c. Or you could write it in as e to the x times x minus 1 plus c, if you want to sort of write it like that a bit. So let's look at another one here. This one's very similar, but rather than e to the x, we have e to the 4x. So we're using the Lipit rule the same way. This is going to be our u term, and the rest is going to be our dv term. Okay, so u, or du, from the last time actually, just from the last last part question, we still found that du is equal to dx, so just leave that there. V is the integral of dv, so that's the integral of e to the 4x dx. Now the integral of e to the 4x dx is e to the 4x over 4. Okay, so what just know how to work with exponential terms like that. This is just a general sort of rule of thumb. The integral of e to the ax, where a is some sort of constant dx, is e to the ax over a plus c. Okay, you just divide by the constant. That's the rule there. We have everything we need again, so let's just work it out again. So just going to scroll down here. uv minus integral of v du. So u is equal to x. V is equal to e to the 4x over 4 minus the integral of e to the 4x over 4 dx. Remember, du is equal to dx. What I'm going to do here is I'm going to take this this quarter term, 1 over 4, I'm going to take it outside the integral. Okay. So just rewriting it like that. The integral of e to the 4x is, again, e to the 4x over 4. So what we have here now, this is equal to x times e to the 4x over 4 minus 1 quarter times e to the 4x over 4, okay, plus c. And what we could do there is we have that minus 1 quarter times e to the 4x over a quarter. Let's just put that all over 16. And get rid of this. And get rid of those brackets now, we don't need them anymore. So that's the answer there. This one. There we go. So x times e to the 4x over 4 minus e to the 4x over 16 plus c. Okay. So that's the answer to that one. So we'll do one more. X times log of x dx. Now this is the Lipit rule again, and this time the polynomial term is second in precedence. So this is logarithm. So this term, this component here, is going to be u, and the rest of it, x times dx, that's going to be dv for us. Okay. So u is equal to log of x. Okay. Oops, my pen slipped there. Let's just do that again. That is equal to log of x. Du dx is simply equal to 1 over x. So du is equal to 1 over x times dx. Okay. V is the integral of x dx. So v in this dv here is x times dx. And so that is equal to x squared over 2. Okay. So let's put this all together. I just made more space there. I'm just going to go back up here. So uv minus the integral of v du. So u here is log of x times x squared over 2 minus the integral of x squared over 2 times du, and du is 1 over x times dx. Okay, so what's going to happen here is we have x squared and 1 over x. That cancels out. So that just becomes 1 over x. This cancels out altogether. Or x squared divided by 1 over x just becomes x. Okay. We have this half term here. We'll just bring that outside the integral. Okay. So what we're left with now is just x. Okay. So let's just rewrite all that again. So what we have here now is x times dx. Okay. So the integral of x is simply x squared over 2. So yeah. So x squared log of x, I'm just reordering the first component there, minus 1/2 times x squared over 2. Let's multiply the half by the x squared over a half. That gives us x squared over 4. And plus c. Okay. So that's 3 integration by parts questions there. That's a lot done. We'll leave it there. We'll do another one very similar now shortly.